All right. Here we go. We're going to run through our practice quiz and make sure we're ready for tomorrow. Now, those of you, we had the other practice quiz on the board, but those of you who actually wrote down those problems, they were exactly the same as the ones on the quiz. These are exactly the same as the questions on the quiz. So if you think, we're going to go through this together now, but if you think you might want to do it again later, take a picture of it so that you have a blank one. If you think you might want to practice before we actually take the quiz tomorrow. Okay, so number one, I've got 2 points, A and B. Little caution, on the quiz I used P and Q, M and N. Doesn't make any difference, right? We're going to do it exactly the same no matter what letters we call our points. How do we find midpoint? We want to find the midpoint of this line segment. How do we do that?
X1 minus
Add them and divide by 2. And when I say add them, I mean add the x's and add the y's. So 1 plus 4 is 5 divided by 2. I add the x's and divide by 2. Now, unless you know how to do that, write that down over to the side because you may not remember how we got 5 over 2. So if you don't know how to find midpoint, write it down so when you study tonight or tomorrow or whenever you study, you'll get it. Y's. 3 minus 5, I'm adding. 3 plus negative 5 is negative 2 divided by 2 is negative 1. There is my midpoint. Okay? Easy points. Now, what does this mean? What am I supposed to do for that second part of that problem? Distance formula. So that's when we have the big radical. X minus x. I heard somebody say it. So 1 minus 4 and square it plus 3 minus negative 5 and square it. So it's x minus x squared plus y minus y squared. All right, here we go. What's 1 minus 4? Negative 3 squared is 9. You can show as many steps as you need to. What is 3 minus negative 5?
64. Well, 8.
8 squared is 64. 9 and 64 makes 73. Little word of caution. When I'm writing these things up, I'm just making up numbers. This one turned out to not reduce. Root 73 does not break down. But the one you get tomorrow might be root 72. And then that's when you do the tree thing and break it down. You need to do that to get full credit. Okay?
My question is, if you continue to keep breaking it down, say you get 2 pairs of 2, don't you do 2 times 2?
You do. That's exactly right. Yep. Yep. All right, now we've got one like some of you are a little bothered by here. We're going to write this as an interval. Now there's only one number. When there's only one number, that means you're either going to be using negative infinity or positive infinity as your other number. Since it's going this way in the shading, we'll use negative infinity.
Yeah.
Yes.
And it has to go on this side of the 5 because on the number line, this is on the left of the 5. So it has to go like that. Infinities are always open. And in this case, so is the 5 because of the dot. Well, looky here, I simplify. Do this however you want, but again, I think it's easier to take care of anything that's negative in step 1. So I'm going to bring this guy down to the bottom. Now everything's positive and I can start combining and canceling. So I got a 3 over a 9.
1 over 2.
1 over 3, right? Now, you don't necessarily need the 1 as long as there's something else up there, but I'll go ahead and write it for now. So 1/3, good? How about the x's?
X, or you take the 2 from the bottom.
X to the 2, x to the second, on the top, right? And then a
15.
total of 13y's on the bottom. One step at a time, you can do it. Some of you try to do stuff too fast and you get not good results. Speaking of doing things too fast, do not get wild and crazy. One step at a time. What's this?
-1.
Well, that's -1.
But then
Inside the absolute value makes it
1.
1. All right? What's this? 5. I am subtracting them, so the answer to the problem is
-4.
-4. This better be an easy question. What is my center? 4, -1. Everybody good with that? Remember, the center is the opposite of the parentheses. The center is the opposite of the parentheses. What's my radius? Well, the square root of 18, which some of you have already reduced to 3√2. And the reason that it's 3√2, for those of you out there in La La Land, is because there's 2 3's and a leftover 2.
Or would you if you break it down to 9 times 2, would that work also?
Absolutely. Then square root of 9 is 3, so it's 3√2. That's exactly right. Now, there is a sister problem to this one. Because if you know how to find the center and the radius, you know how to write the equation. So if I said, so instead of this question, if it said, write the equation of the circle with a center at 5, -3, and a radius of 7, write the equation of the circle, what would that look like? Burkhart?
X minus 5 squared plus y plus 3 squared. And what was the radius? That'd be a 49.
That'd be a 49. Because you're doing exactly what you did there backwards. The center is the opposite of the parentheses. So would this center be 5, -3? Yep.
Yes.
And the radius is the square root of that number, and the square root of that number is 7.
My question is, will it always be positive in that between the?
Yes,
Always?
that's a plus, yep. If that's a minus, you do not have a circle, you have a hyperbola. So that's gonna be a plus every time, if you're doing circles. All right, so that's that. That's our quiz for tomorrow. Put that away then.
Oh, cool.
Yeah, I'm not totally crazy. Just a little bit. It's a great way to end your day.
Will it be a combination of this one and the last one?
It's that. I don't know how else to say it. That's the quiz. You guys act like I'm trying to trick you. I am not. I'm telling you that's the quiz. In a different order, with different numbers, but that's the quiz. All right, so now we're back in our notes, trying to finish up some work we started yesterday.
Is the stuff we're learning today gonna be on there or no?
Oh my gosh.
I'm just making sure. I know. I'm just
My
making
eyes
sure.
twitching.
No.
Okay, let's get this straight one more time.
That's the only stuff that's gonna be on there.
Yes. The quiz you take tomorrow will have exactly those kinds of problems in a different order with different numbers but that's it, okay? So we just reviewed. Now we're gonna set that aside. See, now you got me all hot, and I gotta take my sweater off. Okay, here we go. I do not tell lies, and I do not try to trick you. When I tell you that's what's on the quiz, that's what's on the quiz, period. All right, now here we are on page 3 of our notes, and we're ready for problem 3, which is just some equations to solve. Now, they are of varying levels of difficulty, so we need to make sure that everybody's comfortable with solving these equations. Okay, there's a whole bunch of them. Whole page, the rest of the page is all these different equations. So this one should be a no-brainer. Everybody in here knows that you're going to add 9 and divide by 2, right?
Yeah.
So we got 6. That's like the most basic of all. This one's pretty easy too, but there's x's on both sides, which means we just got to move them around. So x is on one side and the number's on the other side. So you can do that however you want. If I subtract 3x, which you could add 2x, whatever you want, I'd have this. And some of you can do this in one step. You may not need to write down 2 separate steps, but I'm going to. I got 2 as my answer, did you? Now again, no rules about how much work you have to show. If I can do stuff in my head, I assume you can do stuff in your head too. So if you need to have step by step, there it is. If you can do more than one thing at a time, that's fine. All right, now we got the fractions. Fractions always drive us crazy. Somebody at some point told us that fractions were our friends, and they lied to you. Fractions are not our friends. We do not want fractions in our problems. So there are a couple of options you have here. I think the easiest one, you're trying to solve for x. So if this makes sense to you, the easiest thing to do is to multiply both sides by the reciprocal. Because what happens when you multiply 3/2 times 2/3? They're gone, and you're left with exactly what you wanted, which is x equals. And how do I multiply fractions? Straight across. So that's 12 over 10, which reduces to 6 over 5. Now, if you did that a different way,
Oh, yeah, that's how I was gonna ask.
I'm perfectly fine with it as long as you got 6/5. If you got 6/5 as your answer, don't ask me. It's okay. If you didn't get 6/5, then don't do it that way. As long as you're getting 6/5, your strategy is perfect. All right, now we got another one that's got even more fractions in it. So this is another situation where you've got more than one option. Because I know what's coming down the pike, I'm going to make a suggestion to you, but it isn't a requirement at all, but it will make our life easier down the road in some other problems. I have a 3 as a denominator and a 4 as a denominator. What would be the common denominator for 3 and 4? 12. So here's what I'm going to do. I am going to multiply. Oh shoot, can you see that? Oh, it's not very good. I'm going to multiply every single piece of this problem by 12. Now the reason that I did that is because what happens when I take 12 times 1/3?
It turns into 4x.
It turns into 4. So that becomes 4x. Because 3 goes into 12 4 times. So I'm left with 4x. Now what happens here?
It turns into 3.
It turns into a 3. Now I have one of those super simple equations and I don't have to do any work with fractions. So I eliminated the fractions right from the beginning. Now, you don't have to do the problem that way. If you did it a different way and got this answer, I'm totally good. Let's not confuse the issue. Do it your way. But this is the answer you got to be coming up with. All right. What's next? Okay, now we've got one with a bunch of parentheses in it. Okay. This is when you really got to think about PEMDAS, because before you start combining or moving, you got to get rid of those parentheses, right? What property are we going to use to do that? That's right, we're going to use that distributive property. So here we go. 15z minus 9 minus 8z, watch it, minus 4 equals 5z minus 2.
So
let's clean this up over here. We got some like terms over here. So that'll make 7z minus 13. And then we'll subtract 5z. Add 13. I got 11 halves. Which of course you can write as 5.5 if you want to, 5.5. 11 halves is fine. All right, now we've got another one that's just got one fraction in it.
So, on this one, like a one like this, wouldn't you just times it by 3 to make it the right?
Absolutely. But when I times by 3, I have to remember to times everything by 3. So this is going to give me 6x minus 12 equal to 4x minus 5. Remember, kids, when you multiply this 3 over to here, it's gone. It canceled. So you're just left with 4x minus 5. And then 2x equal, I got 7 halves.
Yep.
Now again, as I go through, I'm writing down less and less. Write down as much as you need to. Write down as many steps as you need to keep yourself organized. Now we've got a disastrous mess here. You already did it? Well, you're an amazing human being, Sam. Let's see if you're right. I have no idea what the answer is. Let's see if you're right.
Everything by 12.
I would think that would be a great choice. That's what I'm going to do. I'm going to multiply everything by 12. Now, why did Sam choose to multiply everything by 12?
That's the greatest common factor.
That's the common denominator. That is right. That's the common denominator. Now, the reason that he did that was so he could cancel the fractions. We don't want fractions. So if we can multiply and get rid of them, that's what we want to do. So 3 goes into 12 4 times, leaving me with 4t minus 4. Right?
Yeah.
And what happens here? 4 goes into 12 3 times, leaving me with 3t plus 15. And 2 goes into 12 6 times, leaving me with just a 6. So I have over here, I have 7t plus 11. I just combine my terms over here. So 7t equals -5. Did you say -5/7, Sam?
Yes.
Yeah.
You were exactly right on target. Good job. Everybody good? Look at the next section. These look exactly the same, except what? What's the only difference here in this?
Others, less than, greater than.
Exactly, they're inequalities. Now, inequalities work exactly the same way as equations. So everything that you did here, we're going to do. There's just one special little thing you have to be careful of with inequalities. Anybody remember what it is?
Flips the sign on negatives.
What flips the sign?
Negatives.
Not all negatives. If you multiply or divide by a negative. So, like this problem right here, when we multiplied everything by 12, that would be perfectly fine in an inequality. But if we multiplied by -12, we would have to switch whatever sign was here. Otherwise, we do everything exactly the same. Okay? So, here's what we're going to do. Let's try A on your own paper. Would you try A? See what you come up with as an answer to A. Then we're going to talk about B because it's a little bit tricky. I did number A both ways. And when I say both ways, I mean I put the X's on the left and I put the X's on the right because you can move in either direction. What I want you to see is you get the same answer. If I do this, if I subtract 4x and add 1, this is what I get. When I divide by the -2, I have to switch that sign. So how many of you got x is greater than or equal to -2? Okay, you did the right thing, good. Now if I go the other way and move the x's over to this side, then I end up with this.
Yeah, it doesn't move, but it's still the same thing.
This is the same thing. Do you see that? It's the same as this. X is greater than -2, x is greater than -2. Now the reason I wanted to do it both ways is because you're not asked to here, but on the test you're going to be asked to solve and graph. And I want you to be really careful. That's easy to graph. I think everybody would graph that correctly, right? You would all do that. You'd be perfect. But if it comes out this way, be careful. That means this. So you are graphing that direction, even though that looks like you're not. When you graph, make sure you put your X first. So if it comes out like this, you probably want to turn it around. Toby, you awake? Yes, hurry up, go get a drink. Do some jumping jacks, turn a cartwheel. All right. Next. This one's a little tricky. Real simple to do though. You're trying to get x by itself, right? We're going to subtract 6, but we're going to subtract 6 from everything. And that's going to cancel that out and leave us with our answer. That's it. That's all there is to it. Isn't that easy? A little bit of review. If I said write that as an interval, could you write it as an interval? Yeah. A bracket at -4 and a parentheses at 3.
Yeah.
If I said graph it, no problem. Closed dot at 4, open dot at 3, shaded in between. Easy peasy. Alright, now we got some bigger problems here. So, would I have a couple of volunteers to come up and put C on the board and D on the board?
I can do C.
You can do it? Great, come on up.
I'll do D.
Okay. Remember, you never have to come by yourself. You can always bring a friend if you're a little bit unsure. But you're welcome to do it on your own. So there's C and here's D. Alright, and the rest of us should be working on these at our seats. Yeah. Yes, hurry up. We don't have that much time left. Hurry up. Still no word on our friend Connor.
I think he's done.
We think he's gone?
Yeah, he is. Where'd he go?
How come he doesn't like tell school? They still think he's here. I have no idea. I'm gonna let the class go. What do you think about Pat? Pat's done already.
That's what I got.
That's what you got? Everybody got that. Good job.
I got the best grades.
Now, what if I ask you to write this one as an interval? Now think about it for a minute. Looks like this. So what would be our two numbers when we write as an interval?
-1 and infinity.
-1 and infinity. That's exactly right. And they would both be open. And they're in that order. This was a bigger problem. You done?
Yeah.
All right. What do you think? I haven't done this one yet. What do you guys think? Did he hit this? Is he good?
Yeah.
Everybody's in agreement? Awesome. What would this one be like as an interval? This is a picture of it.
-infinity.
-infinity to 5. Both of them open. Perfect. Perfect, perfect. All right. Everybody okay? Any question about those two? Okay. Nice work. All right, we got a bunch of fractions again. So Shiloh, what are you thinking? We got a bunch of fractions. I think that's a great choice. And when you multiply by 6, you're going to remember these are quantities. So you're taking 6 times the whole parentheses. But really, we're not going to end up using 6, are we? Because the reason we did that is to cancel this out. So we're going to really multiply the first one by 3. So 9 minus 3x. And the second one by 2, so 10x minus 4. Don't let me make a mistake. Am I good so far?
Yes.
And then less than -6. Collect like terms, so it looks like I've got a 7x plus 5. Just adding up like terms. And a 7x less than -11. Do not switch that sign.
That's what I was saying. You don't.
No,
So you
we don't switch the sign. You only switch the sign if your divided by number is negative. Your divided by number is positive. So the sign does not change. One more, and this one is really tricky. You can do it, but just slow down. This one's a little bit crazy. Now I know you've got a 1/2 and a 3 in there. One half and 1/3, and you can get rid of that, but I've graded so many papers over the years, and the mistakes that are made, and when you try to do that off the bat, are incredible. There's a lot of them. So I would suggest, and again, it's just 39 years of practice, I would suggest that you distribute first. Just go ahead and distribute. Get rid of those parentheses. Now, we're going to have some fractions then, but they're going to be easier to get rid of at that point. So we're just going to distribute. So this is going to be 1/2 x, and what's this going to be?
1/2. 1 and 1/2.
1 1/2, or I'm going to leave it 3/2. It's easier for me to work with 3/2. Remember, when I multiply, it's straight across. So 1 times 3, 2 times 1, plus 2x minus 8. All right, over here, I'm going to have 1/3 x and minus 1. Now, if you want to get rid of the fractions at this point, we're going to multiply everything by 6. But we're going to multiply everything by 6 now. So 6, 6, 6, 6, 6, 6. 3x plus 9 plus 12x minus 48, 2x minus 6. All right, take a look at that and make sure that's what you got.
Wow, I'm
Just took one at a time. 6
so you
times
times
a
every
half.
single number by 6.
Every single number by 6.
Could you just put them in parentheses and then like each pair put in parentheses and then just times it by 6?
You can
Would that
times
work?
this by 6, this by 6, and this by 6.
Yeah.
Yep.
That's what I was.
Yep. But again, just make sure you're ending up where I am. Make sure we're getting the same answer, which I don't have yet. So I got 15x minus 39. Anybody got an answer? I got x is less than 33/13. What? I don't know.
That's what I got. I got that.
Somebody got that. I added this and got 15, and that makes negative 39. So I brought the 2 over and moved the 39 over and divided. I think that's right.
Why did you multiply those up there by 6 again?
Because I had in my problem, the black part here is my problem. I had a 1/2, so I had a 2, and I had a 1/3, which is a 3. And the common denominator for 2 and 3 is 6. And if I can't multiply just some things by 6. If I decide I'm going to multiply by 6, I have to multiply everything by 6.
Okay.
So what'd you get so far? Yeah.
What'd you get?
Yeah.
That? Did you copy mine or do it yourself? Get it? Good. Okay, good work. All I want for Christmas is some new erasers, people. Keep that in mind.
When's your birthday, Mrs. Ford?
Huh?
When's your birthday?
Christmas Eve.
Oh.
Okay. All right, so here we go. Here we go. Now we're going to start P4, which is our part that deals with slopes and lines. So again, these are things you've done. Nothing confusing here. Find the slope of the line through these 2 points. All right, now gather your thoughts. We're not doing midpoint. We're not doing distance. We're doing something different now. We're doing slope. Mr. Stewart.
So y2 minus y1 over x2 minus x1.
That's exactly what it is. So when we find slope, and M is the letter we use for slope. I should know why, but I don't. Google it. M is the letter we use for slope. And to calculate it, we subtract our y's and subtract our x's. So y2 minus y1 over x2 minus x1. So the slope is going to be a fraction. We're going to end up with a fraction. And for this problem, we're going to get 8 minus 2 over 6 minus negative 1.
6/7.
The biggest mistake you're going to make is with your arithmetic. Be careful. 8 minus 2 is 6. And 6 minus a negative 1 is 7. Now, I want to be real clear about something. I don't know if this is x1, y1, or this is x1, y1. It doesn't make any difference. If we went the other way, if we did 2 minus 8 over negative 1 minus 6, we are going to get the same answer. It comes out to be negative 6 over negative 7, which is still 6/7. So what am I telling you? I don't care what order you subtract in. It doesn't matter. The order you subtract doesn't matter as long as you're going the same direction on the top as you are on the bottom. So if you're going to do this x minus this x, then you got to do this y minus this y. But you can go the other way. You can do this y minus this y, this x minus this x. Doesn't make any difference which order you go, but make sure they are both the same direction. Second minus first, or first minus second, both times. All right, find the slope of B for me. What's the slope there for problem B?
You want me to tell you it?
-1.
-1.
Is it?
Yeah, -9 over
Negative
9.
1? So 10 minus 1 over negative 3 minus 6? You're right. It is negative 1.
Wait, but I did 1 minus 10. I thought it was y2 over y1.
Doesn't matter. You can do whichever.
Here it goes again.
Way, dude.
I just said that, Mr. Bailey. Pay attention.
I'm trying.
Yeah. No, if you can always do second minus first. So if you always want to go this way, that's fine.
Yeah, that's
You
what
will
I
always get the right answer. But you can also get the right answer going the other way.
Okay.
But you never have to mix it up. You can always do it the same way. Yep.
Why do they even make it like back? Why is it? Why should take? Why would they try to? It's like y2 minus y1. So just keep it.
Well, you mean to say y minus y?
Yeah.
Okay, that's what we're thinking, but to the mathematician, you can't have the same letter. So if you said y minus y, that's going to be 0, because y is y. You can't have, in the same problem, y have two different values. So this is to distinguish them, they called one y2 and one y1. They could have called one big Y and one little y or whatever, but this is just the notation that's used. But you're right. If I'm doing a problem and I have to find the slope, I'm thinking y minus y. I'm not thinking with 2's and 1's and all that. It's y minus y, x minus x. You're exactly right. Okay, now, 2 is a little bit trickier because they tell you what the slope is. So we've got 2 points, and they tell me that the slope is 3/4, and you have to figure out what that missing part of the point is. But if you were listening to what Shiloh was just saying, and what Logan said, you know that anytime slope is involved, you're going to do y minus y and x minus x. So I'm going to do that. I'm going to do 6 minus 5 and x minus 4. Y minus y, x minus x. I can't solve that except that is the slope, and that has to be equal to 3/4. When I do x or y minus y, x minus x, that's slope. And they tell me in the problem that that slope equals 3/4. Okay? Mr. J, you're hurting my self-esteem. All right, you got it? Now, we're going to cross multiply. I would probably simplify that first. I would probably make that 1 over x minus 4, and then, yes indeed, I would cross multiply. So 3x minus 12.
She subtracted the 6 and the 5.
Subtract the 6 and the 5. Now I'm cross multiplying. So 3 times x, 3 times 4, and 4 times 1. That's how we solve a proportion. So 3x equals 16 and x equals 16/3. And you're noticing, I hope, as we go through these problems, that most of the time we don't get nice, neat numbers. We're in big people math now, and we just get all kinds of crazy answers. Where did I get what? Added 12. I multiplied this and got 3x minus 12. Multiplied that and got 4. Solved the equation. So I added 12 and divided by 3. All right, we're going to do one more, and then you get to escape. Same exact thing. Give it a shot on your paper. See if you can get B done. 3, -2, and 1y are the points, and the slope is -2/3. Now, when you write -2/3, either put the negative on the top or on the bottom. It doesn't matter, but it only goes in once. So it's either -2, +3, or it's +2, -3. So let's do our slope. Are you doing y minus y? And I got y plus 2. Y minus -2. And then I did 1 minus 3. And that has to equal -2/3. Now, I'm going to cross multiply, but I like to fix that first. So y plus 2 over -2 is -2/3. Please don't cancel anything. Nothing cancels.
Oh, I thought they did.
No! Put a plus sign in the problem, there's no way to cancel. You can't cancel without a plus sign in the problem. So here we go. 3y plus 6 equals 4. I cross multiply. So 3y equals -2. And y equals -2/3. Anybody get that on your own?
Yes.
You are awesome human beings. All right, after I close tomorrow, we'll pick up there. Please spend a couple moments looking over those quiz problems before class tomorrow.